functional verification and simulation. Okay, so we'll see, this is the sixth topic. So we know that what is functional verification. In order to test the functionality of the DUT, what you will do, we have to write one test bench, right? So that is what they are talking about, the functional verification. Okay. So the test bench is created based on the specification of the design, and there are mainly three functional verification approaches: black box, white box, and gray box. So basically they are categorizing functional verification into three major categories. One is black box verification, one is white box verification, and one is gray box verification. And usually they are telling that either we will perform this verification in event based simulators or in cycle based simulators. So two types of simulator we can use to perform different type of functional verification. Now coming to first approach, that is black box verification approach. Okay, now so you see here, this is your DUT. Okay, so nothing is visible inside. Nothing is visible inside means you don't know you don't know the what is the architecture of this device DUT. Okay, only you know the interface specifications. You know input ports, and you know only ports. Okay, you don't know anything about the architecture details. So such type of verification, when only this much port information is given to you, during that time, if you're performing some verification, that you will call that as a black box verification. Okay. So the test bench is created based on the block specification. The error in the design can be detected only at the output, since the approach does not provide insight into the design details. So what we have discussed now, like we don't know about the details of the design. So to stimulate the error, exhaustive test vector need to be authors. Since we don't know the architecture in-depth detail of the design, so we have to clearly we have to write a lot of test cases to find the real bugs. Okay, so what is the functional verification that black box verification tries to do? What type of errors you can find in black box verification? Initialization and termination errors. So suppose you take an example when you are applying a reset. Okay, so during that time so they are explaining the category of errors, like what kind of errors we can find in black box verification. So first type of error is initialization and termination error. Okay, so suppose you are applying a reset, so your variables are initialized to some known value or not. Termination errors, so like suppose any transaction fails. Okay, so what is the reason, what is the source of that error? Termination error you will find. Now you will only find the interface related errors. Okay, interface, you can take example, like you can go with the AHB interface or any protocol side PHY interface. So only you can check at interface level, okay, whether you are getting the expected output or not. So that is what they are trying to say. You will get error pertaining to interface level. Then performance error. Performance error, you can take example of bus turnaround time. Okay, suppose you are forcing an input, right? How much time that DUT is taking in order to process this input and giving you the desired result. So that is what they are trying to say from performance error or performance error. And if you take another example, like you can talk about the CPU, like how much CPU utilization is there. Okay, so all those things you can find in performance errors. Okay, then you can say incorrect or missing functions. So you can also find out, like suppose you have not implemented all the features whatever is available in the specification. So in that case, if you have not implemented those things, or if you have implemented that thing in wrong way, you can catch those type of error. So basically the author has explained the 4 general types of error which you can find with the help of black box verification approach. Okay, that is what they are trying to say. So we know that what next point they are trying to say: poor observability and controllability, making debugging task very difficult. What they're trying to say from this point is like this is black box, right? So we don't know what is inside this box, black box. So in that case it is very difficult to debug, right? You cannot find exactly where is the source of error. You can say just error, you can say that transaction is failed, but you can't go inside and you can say that this is the source of error. So Coming to next type of verification, that is called as white box verification. Okay. So it is the opposite of black box verification. You can say that here observability and controllability is very high. You can you can access each and every corner of the RTL code. Okay. So another name that they are giving for white box verification is structural verification. Okay. So structural verification means that everything is visible inside. Okay, so you see here they have shown one diagram of a white box verification approach. What they are trying to say from this is you are having a DUT, right? So inside DUT you are having different blocks. You are having state machine, you are having FIFO, you are having some modules. So this is the like state machine is mentioned here. FIFO is, suppose you assume this is a FIFO, or you assume some control logic is there. Okay, so everything is visible. Okay, you know each and everything. So what they are trying to say, the stimulus for corner cases can be easily generated, enabling the source of error to be detected and identified. Suppose you want to check some corner cases. So when you transmit 1 byte of data, so during that time your DUT is able to process the data or not. Okay, such type of corner cases you can identify, because and you can write, suppose if FIFO is there, so you can write some test cases for FIFO empty and FIFO full conditions, right? So easily you can check out the boundary conditions also in case of white box verification. So basically this is the most widely used verification that is currently industries are going on. Okay, industry is using. So this is white box verification